Welcome to another session of force systems with me, Srilekha, in lecturer in mechanical engineering, SRRS Government Polytechnic, Agrahan. So, in the previous sessions, we have discussed something theory about the force systems and laws of forces and units of derivation, units of measurements, physical units, and etc. So in this class we are going to discuss about the problems, how to calculate the problems that are related with the equilibrium of forces or the resolution of forces method and etc. So prior to that, let us have a small recap of the topics that we have learnt earlier. First, uh, what is a force? A force is that agent which tends or moves the body which is in a uniform motion to change its position or motion of the body. It brings a body of rest into motion or a body in motion into rest. It may change the uniform motion into a non-uniform motion. So these are all nature of a force. These are all happens due to the effect of force. After that, what are the characteristics of force? Characteristics of force can be defined by four things. The first one is magnitude of force. Magnitude of force is nothing but the quantity of force that is applied on a body. Next, line of the action is nothing but the direction of the force with respect to the horizontal or vertical axis is nothing but line of action. It is the direction in which the force is applied. Next comes sense of the force. It is nothing but it is pull type or a push type one. Next is point of application of the force. Point of application of force is nothing but the exact point on the body on which the force is applied. So these are all the characteristics of forces, and due to the effect of force, what happens? Internal stresses may occur. The body may deform, change in its shape in nature may occur. The change in the moment occurs. So these are all the forces. Thereafter, we have discussed system of forces. System of forces is nothing but a set of forces which are acting on a plane or on different planes. So basically, system of forces were divided into two types. One is coplanar forces, the other one is non-coplanar forces. Coplanar forces are those which act in a same plane. Non-coplanar forces are those which act in different planes. So coplanar forces are further divided into collinear forces, congruent forces, non-congruent forces, parallel forces. Collinear forces are those which whose line of action act in the same line as well as in the same plane because they are coplanar. Next, if two lines are acting in the same plane and are passing through a same single point, then they are called as congruent coplanar forces. Next, if two forces are parallel to each other, it means they are they are equidistant from each other and are acting in the same plane, then they are said to be parallel coplanar forces. Next, the forces which do not pass parallelly, which do not intersect each other, are called as non-parallel, non-congruent forces. Next, non-coplanar forces are those which are completely acting in different planes. Again, these non-coplanar forces can be divided into various types. One is congruent, the forces which do not pass through the same plane but pass through a single point, called as congruent non-coplanar forces. Next, non-parallel, non-coplanar forces. The forces which are not equidistant from each other and lie in the same plane, other planes are nothing but non-parallel, non-congruent forces. So likewise, we have different system of forces. Then after, we have discussed resolution of forces. Resolution of forces is nothing but splitting of a single force into horizontal and vertical component without changing its effect. The example is, we have taken, for example, F is a force acting on a body. Now if I want to resolve this, if this force is acting at an angle, then the horizontal force is F cos theta, the vertical force will be F sin theta. Now again, if I take something like next is composition of forces. If if the force, if a number of forces are applied on a body or acting in the same plane or other planes, if they are congruent, then there will be a single force which can replace effect of all these forces is nothing but resultant. Combination of all these forces to a single force is nothing but composition of forces. Next, we have equilibrium. Equilibrium is nothing but a body is said to be in equilibrium if all the forces acting on a body are making it in a balanced condition. If the body is in a balanced condition, then it is said to be in equilibrium position. So equilibrium position can be attained when the forces acting on both the sides are equal. When the forces on LHS equal to forces on RHS. Now to satisfy the single force which will bring the entire system into equilibrium condition is called as equilibriant. Equilibriant. Now, for this equilibrium condition, we have three major conditions to satisfy this equilibrium. First one is the sum of horizontal components should be equal to 0. Means see, we are splitting single force into two components, horizontal component and vertical component. Say if three forces F1, F2 and F3 are acting on a body. Now, horizontal component would be if theta 1, theta 2 and theta 3 are the angles made by those forces with respect to the horizontal reference line, then horizontal component sigma h is equal to F1 cos theta 1 plus F2 cos theta 2 plus F3 cos theta 3. So this is the summation of horizontal components. Now this should be equal to 0. So next condition is vertical component, summation of vertical component should be equal to 0. Algebraic sum of vertical components should be equal to 0. That is, sigma v is equal to f1 sin theta 1 plus f2 sin theta 2 plus f3 sin theta 3. Now that should be equal to 0. Next, the last condition is that the algebraic sum of moment of forces should be equal to 0. So sigma m is equal to if so moment can be calculated by force into perpendicular distance, that is nothing but arm of the force, arm is nothing but for perpendicular distance. So sigma m equal to F1 L1 plus F2 L2 plus F3 L3 and so on, where L is the perpendicular distance from the point of application to the source of application. Okay. Next, thereafter, we have discussed something regarding the uh, resolution method. Not resolution method, there we have discussed about the parallelogram law. So in the parallelogram law, we have discussed that if two forces passing through a point are represented by adjacent sides of a parallelogram, then the resultant would be represented by the diagonal uh, passing through the point passing through these two sides of the parallelogram, both in magnitude and direction. Basing on this statement, we have derived a resultant, that is r is equal to under root of p square plus q square plus 2pq cos alpha, where alpha is the angle between the two forces P and Q. P and Q are the two adjacent forces. R is the resultant. Thereafter, we have found the angle made by the resultant with the horizontal component. Therefore, that theta is equal to tan inverse of q sin alpha by p plus q cos alpha by p plus q sin alpha. So this was the formulae which we have derived by making use of parallelogram law. Thereafter, we have discussed triangle law. So triangle law is nothing but if two forces are represented in magnitude and direction by the two sides of a triangle, then the third side represents the resultant of the two forces, but in the taken in a reverse order. So this was a triangle law. Next we have discussed Polygon's law. So Polygon's law explains that if number of forces are represented in magnitude and direction by the sides of a polygon, then the closing side is represented by the resultant of those forces. Say if you take a pentagon, four adjacent sides are the forces, and the fifth side would be the resultant. Next, we have discussed Lamine's theorem also. If three coplanar uh, concurrent forces are passing through a point, then the angle, the ratio between the force and the sine of the angle made opposite is is proportional. So P by sin alpha is equal to Q by sin beta equal to R by sin gamma, where P, Q, R are the forces acting through the point, and alpha is the angle between Q and R, and gamma beta is angle between uh, R and P, and gamma is angle between P and Q. So basing on this, we have the formula also. Next class, we have discussed about the method of resolution. If more than two forces are used, how can you find out the resultant, and how can you find the resultant and the direction, magnitude of the resultant and the direction. For that also, we have done something. So what we have done, we have taken the forces, and first we have drawn the axis, that is east, west, north and south. After that, based on the data that is given, we have denoted the forces in their respective places. Say if a force is given on due east, then we have drawn on the east side. If the force is given north-west, then we have taken an angle of 45 degrees and drawn in between north and west. Likewise, we have denoted all the forces in the different quadrants. Thereafter, so by making use of that, we could find theta, that is nothing but angle made with the horizontal, angle made by the forces with the horizontal. Thereafter, we have found the horizontal component, that is sigma h is equal to f1 cos theta 1 plus f2 cos theta 2 plus f3 cos theta 3 and so on. Next, we have found vertical components, that is sigma v is equal to f1 sin theta 1 plus f2 sin theta 2 plus f3 sin theta 3 and so on. Then after, we have found resultant, magnitude of the resultant, that is r is equal to under root of sigma h square plus sigma v square. By making use of that, we could find the resultant, nothing but magnitude of the resultant. The sigma h and sigma v is nothing but the signs of the sigma h and sigma v would trace out the location of the uh, resultant. So based on their signs itself, we could find out the place or the quadrant in which the resultant lies. Next, we have found next we have found that theta theta is nothing but the angle made by the resultant with the horizontal. That theta is nothing but tan in theta equal to tan inverse of sigma v by sigma h. So this was the thing which we have found. Now in today's class, we are going to discuss few problems based on Lami's theorem and method of resolution and all. So here we can see a problem. A circular roller weighing 500 newtons having radius of 200 mm hangs by a string of AC of length 400 meters as shown in the figure. Find tension in the string and the reaction of the wall. So it is diagrammatically represented that a circular roller. So this is a circular roller. It is weighing 500 newtons and it is hanged by a string AC and AC of length 400. So length of this AC is 400. Now this AB is a wall. Now we have to find this in this AC string, the tension and the reaction of the wall. So in what is a free body diagram now? So free body diagram is nothing but the diagram which represents the reactive and active forces that are acting upon a body. Now, so as per the data, we can draw this kind of diagram. Now, free body diagram means it will have only the forces. So here you can see the free body diagram. Where see here it is a circular roller. As you know, weight of the roller always acts, weight of any body will act downwards. So weight of this is W. It is nothing but 500 newtons. It is acting downwards. Next, so it is tied by a string. So since string is tied, it will have certain tension in it. So this is the tension. Next, so as this body is tied by the string, this body comes into contact with the surface, vertical wall. So when it is, this body will try to push that wall. So when it is trying to push the wall, by the wall, certain reaction forces are applied. So that is nothing but this R. Okay, so now I can draw as a circular roller and downwards is W1 and this upwards is T and this right side is RA. Now I want to take the forces, all the forces away from the body. That is why instead of like this, I can extend this force towards this side. So that is why we have taken this RA. Now, so the values are given are nothing but W is 500 newtons and this AC is, let it be length of the string, it is 400 mm, and radius of this circular roller is 200 mm. Now if I take this triangle ABC, out of this if I take theta is the angle between this string and the horizontal. Now this theta is equal to cos theta is adjacent side by hypotenuse, nothing but BC by AC. So BC is already we know, that is radius 200, and AC is nothing but length of this string. So 200 by 400 is 0.5, that is 1 by 2. Cos theta is equal to 1 by 2. Then theta would be 60 degrees. Next, so by making use of this 60 degrees, next the angle made by this reaction with this W is 90. So now the angle made by this reaction with W is 90. Now the leftover thing is angle between next remaining thing is this is 60. So this is 90. 90 plus 60 is 150. So this entire thing means between uh, T, this string and the weight is 150. The remaining thing, leftover thing is simply 360 degrees minus of 150 minus 90, because this the angle made by a complete revolution or rotation is 360. So the leftover would be 120 degrees. Now I will apply Lamis theorem. As you know, T is already uh, sorry this T, and we are known with only W and R. So let P is the force W, T is the force Q, next R is RA. Now for this alpha would be 120, next for this beta would be 90, and for this gamma would be 150. So P by sin alpha equal to Q by sin beta equal to R by sin gamma. So similarly, W by sin 120 is equal to T by sin 90 is equal to R by sin 150. Now on substituting, W is equal to 500. So substituting W is equal to 500 means, so T by sin 90 is equal to 500 by sin 90. So T is equal to 500 into sin 90 by sin 120. Next, RA by RB by sin 150 is equal to 500 by sin 120. So RB is equal to 500 into sin 150 by sin 120. Likewise, we'll get T value as 577.3 newtons and reaction is 228.67 newtons. So this is as simple as it is. Next, so the following forces act at a point are represented in the following diagram. So previous to that, let us once rememorize the representation of forces in a quadrant. Okay. So if first we have to draw this, right, line, directions representing the directions. This is east, north, west and south. So this east side represents nothing but positive x-axis. Now west side represents negative x-axis. Now north side represents positive y-axis. The south side represents negative y-axis. Now, so as we already know, east of north, north of east, east to north, north to east and all we have already explained. Now, so in this it is given first force 40 newtons inclined at 30 degrees towards the northeast. So where is northeast? So this is north and this is east. So this entire region, first quadrant is northeast region. So in this first 40 newtons inclined at 30 degrees northeast. So northeast means you have to take this as your reference line. You have to put your protractor here and measure from here 0, 10, 20, 30 degrees. So from here you have to point a mark at 30, and now you have to join a line from the center. So that is your 40 newtons which is inclined at 30 degrees northeast. Next, 50 newtons towards north. So it is simply said north. So you can simply draw that that force on the north positive y-axis. So 50 newtons on the north. Next, 60 newtons towards northwest. So this is northwest region. See, simply if it is the northwest, you have to simply draw by taking an angle of 45 degrees. So northwest means 45 degrees, it is 60 newtons. So 60 newtons, 45 degrees we have taken. Next, 70 newtons inclined 60 degrees towards southwest. So this is west and this is south. So 60 degrees means we have to take this as base, west as the reference line, and from there you have to take 60 degrees. So by making use of a protractor, we'll draw the 60 degrees and we'll draw a line from that point 70 newtons. So this is all you can denote the force system. So in this we are having 1, 2, 3 and 4 forces. So first force is 40 and its angle is 30 degrees. Next second force is 50 and its angle is 90 degrees. Next third force is 60. You can take angle as 90 plus 45, 135, or you can also take 45. Next uh, uh, next angle is, so this is entirely 180 plus 60, that is 240. Now I'll resolve horizontally. So for horizontally we can take f1 cos theta 1 plus f2 cos theta 2 plus f3 cos theta 3 plus f4 cos theta 4. So f1 cos theta 1 means 40 cos 30 plus f2 cos theta 2 means 50 cos 90. Next third one, f3 cos theta 3 means 60 cos 135. Next f4 cos theta 4 means 70 cos 180 plus 60, 240. Now 240. So just substituting the cos values, then you will get the angle minus, you will get the value minus 42.78 newtons. Next, if I take the forces vertically, if I resolve the forces vertically, so for that formula is f1 sin theta 1 plus f2 sin theta 2 plus f3 sin theta 3 plus f4 sin theta 4. So 40 sin 30 plus 50 sin 90 plus 60 sin 135 sin 135 plus 17 sin 240. So these are all 4. So 20 plus 50 plus 42.42 minus 60.62. So there you will get a value of 51.8 newtons. See, next the formula for resultant is R is equal to under root of sigma h square plus sigma v square, that is equal to 67.18 newtons. Now, direction of the resultant tan theta is equal to sigma v by sigma h, that is equal to, so sigma v is 51.8 newtons by sigma h is 42.78 newtons. So it is 1.21. So theta equal to tan inverse of 50.4. Now, where can we denote this resultant? See, this region is plus and plus, both are positive. Okay, x-axis is positive, y-axis is positive. Here, y is positive and x is negative. Next, in this region, x is negative, y negative. In this region, x is positive and y is negative. So, whatever resultants we have obtained, the horizontal term is nothing but x term is negative. So, x term negative means this west side. Next, y term is positive, means y is positive this side. So your quadrant, your resultant will lie in second quadrant. So what is the angle made? It is 50.42. So from west side you'll measure 50.42 and you'll draw a line. So that is your resultant for this given problem. Okay. So your resultant, whatever I have explained, is the same. So your resultant will lie in the second quadrant and it makes an angle of 50.42 with west. Now if I measure it from this reference line, positive reference line, then it is, the center value is 180 minus 50.42, that is 129.57 minutes. Okay. So this is all the problem. Next let us take. So 5 forces, 20 newtons, 30 newtons, 40 newtons, 50 newtons and 60 newtons are acting on one of the angular points of a regular hexagon towards other 5 angular points taken in order. Find the direction and magnitude of the resultant. So you can see that 5 forces, 20, 30, 40, 50 and 60 are there. Now we need to find the magnitude of the resultant. So first let us trace out these in a quadrant region. So now if I take horizontal and vertical quadrants, so this is my horizontal force. So I am maintaining it on the east. So newtons. Next from here 30 degrees you'll have 30. So from here I'll take 30 degrees and I'll draw 30. Next from here it is again 30, means 30 plus 30, 60. So from horizontal it is 60 and the force is 40 newtons. Next, so 30, 30, 30, it is 90. So from horizontal it is 90 degrees, it is 50 newtons. Next this is uh, 90 plus 30, 120. So from horizontal it is 120 newtons, 60 newtons. Or else from the left side you can take as 60 newtons. Okay. Now, so according to this, my theta 1 is 30 degrees and F1 is 20 newtons. Theta 2 is 60 degrees and F2 is 30 newtons. Theta 3 is 90 degrees and F3 is 40 newtons. Theta 4 is uh, uh, 90 degrees and the F4 is 50 newtons. Theta 5 is 60 newtons. Sorry, you can take 120 degrees and uh, F5 is 60 newtons. So again resolving the forces horizontally, we know sigma h is equal to F1 cos theta 1 plus F2 cos theta 2 plus F3 cos theta 3 plus F4 cos theta 4 plus F5 cos theta 5, because it is uh, there are 5 forces. So simply substituting, we know 20, 30, 40, 50 and 60 are the forces. Theta 1 is 0, theta 2 is 30 degrees, theta 3 is 60 degrees, theta 4 is 90 degrees and theta 5 is 120 degrees. Simply substituting the values. So F 20 cos 0 plus 30 cos 30 plus 40 cos 60 plus 50 cos 90 plus 60 cos 120. So that will give us 35.98 newtons. Next, vertically resolving. Then F1 sin theta 1 plus F2 sin theta 2 plus F3 sin theta 3 plus F4 sin theta 4 plus F5 sin theta 4. So 20 sin 0 plus 30 sin 30 plus 40 sin 40 sin 60 plus 50 sin 90 plus 60 sin 120. So on substituting in the sin values, you will get vertical term as 151.6 newtons. Now if you see, the horizontal and vertical both the terms are positive. It means that the resultant lies in the first quadrant, because the first quadrant is all positive. So R is equal to under root sigma h square plus sigma v square. So that is equal to under root 35.98 square plus 151.6 square. So you will get a value of 155.8 newtons. Next, direction of resultant. Tan theta equal to sigma v by sigma h. So theta equal to tan inverse of sigma v by sigma h. That is equal to 76.6 degrees. So you can simply draw by from the east side 76.6 degrees. That gives you the resultant. Okay. Next, the forces act at a point 15 newtons inclined at 30 degrees towards north of east, 20 newtons towards north, 25 newtons towards northwest, and 30 newtons inclined at 40 degrees towards south of west. Find the magnitude and direction of the resultant force. Now, given forces are have to be denoted on a quadrant, in a quadrant. So first let us draw east, west, north and south. So first what is given? 15 newtons inclined at 30 degrees towards north of east. So in between north and east, you have to draw the diagram. What is the angle? The angle is 30 degrees north of east, means from east you have to draw towards north side. It is not north to east. If it is north to east, you have to draw on the north. You have to take reference on the north and you have to draw to east. But here north of east means on the east you have to take as the reference and you have to draw towards north. So 15 newtons by reference, by taking an angle of 30 degrees, you will draw the first force, that is 30 degrees. You will draw first force 15 newtons. Next, 20 newtons towards north. It means on the north itself you have to draw 20 newtons. Next, 25 newtons northwest. Northwest means you have to exactly take at 45 degrees. So northwest means second quadrant. You have to make an angle of 45 degrees and draw 25 newtons. Next, 30 newtons inclined at 40 degrees towards south of west. So towards south of west means from west you have to draw towards south side, that is 30 newtons at an angle of 40 degrees. So now we are having four forces, that is 15 newtons, 20 newtons, 25 newtons and 30 newtons. Now resolving the forces horizontally. So 15 cos 30 plus 20 cos 90. So let us write first angles. So theta 1 is 30 degrees. From east you have to measure the angles. Next, theta 2, which angle made by 20 newtons force, it is 90 degrees. Theta 3 means the angle made by 25 newtons, so it is 90 plus 45. Okay. Next, theta 4 means the angle made by uh, 30 newton force, it is 180 plus 40, it is 220. So now 15 cos 30 plus 20 cos 90 plus 25 cos 135 plus 30 cos 220. So that will give you minus 27.66 newtons. So now resolving the forces vertically. We know sigma v is equal to f1 sin theta 1 plus f2 sin theta 2 plus f3 sin theta 3 plus f4 sin theta 4. That is equal to 15 sin 30 plus 20 sin 190 plus 25 sin 135 plus 30 sin 220. So that will give us 25.89 newtons. So next the resultant is R is equal to under root of sigma h square plus sigma v square. So you'll just substitute the value 27.66 whole square plus 25.89 whole square. It will give a value of 37.88 newtons. So magnitude of the resultant is 37.88 newtons. Next, direction of the resultant is theta is equal to tan inverse of sigma v by sigma h. So that is equal to tan inverse of 25.89 by 27.66, that is 43.21 degrees. So in this, if you see, the horizontal term is negative, the vertical term is positive. So therefore this quadrant, these coordinates will lie in second quadrant. So h is negative and v is positive, and the direction of this will also lie in 43.2. The direction will be 180 minus 43.21 degrees. So that is 136.79. Next, next problem is a particle is acted upon by forces P, 2P, root 3, 3 root 3P, 4P. The angle between the first and second, second and third, third and fourth are 60, 90 and 150 degrees respectively. Find magnitude and direction of the resultant. So now I have to denote these particles. So let us draw the x and y coordinates reference lines. So on x axis let us take P, and next it is given angle between first and second is 60 degrees. So from x you have to take 60 degrees and draw the line 2P. Next, between second and third is 90. So from 2P you have to take 90 degrees and draw 3 root 3P. Next, from third and fourth it is 150. So from third and fourth it is 150. So you will simply draw from root 3p, 3 root 3p, 150 degrees. So that is your 4p. So now we have to find the magnitude and direction of the resultant force. So now first let us draw the thetas. We have to take the angle of theta. F1 is P. So theta 1 is simply 0. Next F2 is 2P. Theta 2 is 60 degrees. Next F3 is 3 root 3P. Now angle is 90 plus 60. So you have to take from positive x-axis. So 90 plus 60 means 150. Next F4 is 4P. Now the angle is 60 plus 90 plus 150, nothing but 300. So that is theta 4. Now horizontal component is equal to algebraic sum of horizontal component is P cos 0 plus 2P cos 60 plus 3 root 3P cos 180 minus 30, or simply 3 root 3P cos 150 plus 4P cos 300. So values, on substituting the values of cos's, you'll get simply minus 0.49P. Next, resolving the forces vertically. So sigma V is equal to P sine 0 plus 2P sine 60 plus 3 root 3P sine 150 plus 4P sine 300. So that will give you a value of 0.866 T. Next, resultant R is equal to under root of sigma h square plus sigma v square. So that is nothing but you'll get an value of 0.995 p. So tan theta, next direction of the resultant. So tan theta is equal to sigma v by sigma h. Sigma v we got 0.866 p by 0.49 p. So both p's get cancelled. The leftover thing is 0.866 by 0.49. That will give you a value of 1.767. So theta equal to tan inverse of 1.767, that is 60.49 degrees. Now where does your resultant lie? See, in the horizontal component it is negative, h is negative and vertical component is positive. So x negative and y positive means it is second quadrant. So in this region your resultant lies, and the angle is 60.49 means 180 minus 60.49 you have to take. So that will give you some uh, 119.1. So 119.01, that is nothing but 119.51, that is nothing but your direction of the resultant. So these are all the problems for today. So in today's session we have memorized the topics which we all discussed at till today's class. We have discussed free body diagram, system of forces, laws of forces, forces, their impacts, and the causes of forces, the nature of forces and all. And then after we have discussed force, the problems on Lamy's theorem, on a few problems regarding the resolution of forces. I hope this is clear to everyone, and let us meet in tomorrow's session again.